Alright, welcome to class. This is quick class tutorial. And today we are having chemistry questions on nuclear chemistry. Okay, we'll be solving some questions. We've solved some already. So we are adding to the questions we have solved on nuclear chemistry. And I hope you're going to be educated and you will have an eye opener on this subject. So here we will have just 5 questions, alright? 5 questions that you are seeing right now. So the first question here says what? Let's go. Given the information in the table below, alright, very high, not very high, high, very low, low. So which of the nuclei is the most stable? Now this is half-life. Number one question. Alright, this is the half-life. Half-life, and this is the nucleus. So nucleus like an atoms, alright, these are their half-life. So from this table, element R has what? Very high half-life. V has not very high. F high. C very low. And U low what? Low half-life. So if they have very high half-life, simply means the half-life is very large in number, right? So if it has low half-life, means the half-life is low, alright? So that is to say, a more stable nuclei, a nucleus that is stable, very, very stable, tends not to have any half-life because it will not disintegrate, alright? So if you now have a nucleus that is not too stable, it will now have a half-life, alright? But the half-life will take a very long time before it decays. You understand? Like it's going to take a very long time before it decomposes, or disintegrates rather. I don't know if you get what I'm saying. So if a nucleus of an atom, alright, will take a longer time for it to decompose, it means that it's a little bit stable. You can even call it a stable a stable substance. Are you getting me now? But if it takes it takes, in no time and it disintegrates, that means the nucleus is very, very unstable. You understand now? So we are looking at what? A very, very what? We are looking at what? A very high half-life for a stable nuclei. If you have a very large amount of half-life, it means that it's very stable. And it takes time for it to what? Disintegrate. I don't know if you get it. Alright, so nuclei has a very high half-life. That's R. So R nuclei is more stable. Most stable is R nuclei. But most unstable is what? Low half-life, which is U. Alright. So let's go to the next question. Now, two radioactive elements, Q and S, have half-life period of 10 hours and 20 hours, respectively. Therefore, S decays faster than Q. S is twice as stable as S. Q emits fewer particles than S. S is more stable than Q. None of the above. So let's look at the question again. Now, two radioactive elements, S and Q, have half-life period of 10 hours and 20 hours. So you have 10 hours and S has 20 hours. Not really. If you have 10 hours of half-life, are you getting me now? And S has what? You have 10 hours and S has what? 20 hours of half-life. It means that the one that has 20 takes longer time for it to decompose. So for it to take longer time for it to decompose, it means that it's more stable. Right? The one that has shorter time means that it's not really stable. So the one that is twice as stable as, you understand? The one that has 20 hours is twice as stable as what? The one that has 10 hours. Are you getting me now? So S is twice as stable as Q. S is more stable than Q. Yes, S is more stable than Q is correct. But Q is quite as stable as no, it's not. What is S is quite as stable as what Q. So S is more stable than Q. Our option is B. You understand? Option B. Alright, number 3 question. What are the value of X and Y in the following equation? What are the value of what? X and Y in the following equation? Alright, so you have 2, 3, 4, and 90. So it became by delta particle. This is what? Delta particle. No mass was lost. So Y still remains what? 2, 3, 4. Delta particle, no mass is lost. But here, in atomic number, you have minus 1. Minus 1 means that additional mass, additional atomic number. Alright? So here will be 91 because 91 minus 1 must give you 90. Left hand side must be equal to right hand side. So here is 91. So S is what? S is what? 91 and Y is what? 2, 3, 4. 91, 2, 3, 4. Our option is what? A, right? Option A. So let's look at question 4. Oxygen is a mixture of two isotopes, oxygen 16 and oxygen 18, with relative abundance of 90% and 10% respectively. The relative atomic mass of the oxygen is, now let's go again. Oxygen is a mixture of two isotopes, oxygen what? 16 and oxygen what? 18, with relative abundance of what? Of 90% and 10% respectively. The relative atomic mass of oxygen is. Now this question is very, very interesting. Alright, and I would like to solve it. So let's see if we can wipe the board off a little bit here. So let's see this is. So what we have? We have two oxygen. Oxygen 16, that's the first one. Then oxygen what? 18. The abundance is 90%. And the abundance of this one is what? 10%. What is the relative atomic mass? Now this is how to calculate the relative atomic mass. Alright? You will just take the abundance of the first one, 90, divide it by 100, then multiply by the mass, the atomic mass, plus the other one, the abundance 10%, divide by what? 100, then multiply by what? The abundance times 18. That is how to get the atomic mass for any, that is how to get the relative atomic mass for any atom at all. Alright? Given the abundance or the ratio, either they give you the ratio or the abundance like this. If I give you a ratio, now this ratio will be what? 9:1. So if I have ratio of 9:1, how will I solve it? Just like you have 90%, 90 over 100 in percentage. So when it comes to ratio, it will be what? 9 over 10, or 9 plus 1 is 10. Just like you have 90 out of 100%, right? So the same thing, 9 out of 10. So you're going to give 9 over 10 times 16 plus what? 1 over 10 times 18. It's the same method. And of course, if you divide this, you're going to get the same thing. Alright? So either they give you a ratio or a percentage. So we're going to use either this one, alright, or this one here. I don't know if you understand what I'm saying. Are you getting it? Good. So to clean the box further so that we can have a simple and clear calculation. So now if we want to use this one, because this one will also give us this. Now let's use this one. So 1 9 over 10 times 16 plus 1 over 10 times 18. Alright? So what do you have? 9 times 16. 9 times 16. I do it somewhere. 9 times 16. 9 times 16. That's what? 30 what? 9 times that's what? 54. Right? 4 times 5. 9 times 1. 9 plus 5. That's 14. So 144. So we have 144 divided by 10 plus 18 divided by 10. So if you are dividing by 10, you know you are moving the decimal backward, right? So I move the decimal backward, so I have 1.4 plus I move the decimal backward, I have what? sorry, 14.4, not 1.4, plus 1.8, okay? So add these two. What you have, you start adding by their value system. So let's add it. This one is 1 decimal place, this one 1 decimal place. So 4 plus 8, right? That's 12, right? You write 2, then put your point, add a 1. Add the 1 to this one, that's 2. 2 plus this one here. Because this is unit. Can you see? Unit. Unit. Alright, this one is tens. So you add according to their decimal, their value. Their place value. Okay? Alright, so this is 1 and this is 4 plus the 1 and 2 over. So that's what? 6. 4 plus 1, right? Plus another 1, 6. So here is 6. Then of course, there's no other one. This one is 10. And this one does not have 10 value, so just put 1 here. So the relative atomic abundance is what? 16.2. 16.2. And finally, the last question. What is emitted during the disintegration of barium nuclei as shown by the equation below? What's emitted? What's emitted? What is emitted? If barium having atomic mass of what? 138 became 134. It has lost 4. 138, it became 134, it has lost 4, right? So 4 has been lost. Now, 56 became what? 54. How many lost? 2. When you have atomic mass of 4 and atomic number of 2, that is what? Alpha particle, or otherwise known as what? Helium nuclei. So alpha particle was decay. You understand? So our option is what? Alpha particle. Thank you for paying attention. So please do well to subscribe. I hope our students in the hall you understand, right? Okay. So please do well to subscribe and follow us on all platforms. Remember, this is putting up tutorial. Whenever you see Mr. Brain, you know that you are seeing someone that is committed to help you to score very high. Very high, no other reason. We are here because we have seen many students score very high. Thank you.